Hey class, hopefully you are doing quite wonderful right now. This is just a little bit of an instructional video for our Vo2 Max lab. So this lab will take quite a while because what you're going to be completing for this is one non-exercise test and three exercise tests. So I want you to take your time in completing all of these and reach out, ask questions. Of course, you can't do all of these on the same day. I would recommend that you take at least 24 or 48 hours between all of these tests. But here, let's go ahead and get into this VO2 Max. So what you're going to turn in, you have the choice of either a short video of yourself running these tests on yourself or on a friend, and or you can take a bunch of pictures illustrating every aspect of the test. Again, prove to me that you did this test with all of these pictures. Next thing, worksheet with all of your answers highlighted, and as we always do, with this is what you turn in. Everything on down from there is what you will be turning in, of course. So now let's just get into a little bit of background on this Vo2 Max and what all of this is. So put as simply as I possibly can, Vo2 Max is just your ability to transport and utilize oxygen. So we have a few different ways of representing it. So we have absolute values and relative values. So absolute values are just the amount of oxygen that you can transport in liters per minute. So this is very frequently going to be a very small number. So if someone had an absolute VO2 max of around 5 or so, that would actually be pretty good. I actually measured an individual that just went into the NFL. He was a lineman, and he had a absolute VO2 max of 6, or it was actually a little bit above 6. However, in comparison to his relative VO2 max, which relative, that means relative to an individual's body weight, um, is milliliters of oxygen per kilogram of body weight per minute. So even though his absolute VO2 max was really high, being around, 6 or so, his relative VO2 max was actually just about around average, about a 40 milliliters of oxygen per kilogram of body weight per minute. So these VO2 max, it's a really good predictor of performance, especially whenever we look into the aerobic domain. So, cross-country athletes, any endurance sport, anything that really lasts longer than, I don't know, about a mile or so, then VO2 max seems to be really good. And also, it's a good predictor of how, strength and explosive athletes, how they're going to recover between maximal exertions or, submaximal exertions. You're not going 100% all of the time. Another thing that this is really good for is predicting how long you're going to live. Really, there's only a few metrics that we can take and use and say with pretty good certainty scientifically that the higher this number is, the healthier you are, and the faster it declines over the end of your life. We can actually predict uh, pretty close to the month that you will die if we look at the rate of the decline in your VO2 max or your aerobic capacity. That's another way of saying that. So with all of this, you can read all of these different things, but since we're doing this online, we're not going to be doing what is technically considered the gold standard. The gold standard would be getting on a metabolic cart and actually measuring expired gases as we take someone through a graded exercise test. So hopefully you've seen this on the internet or in movies or something before, where somebody puts on a mask and they're breathing into it and they're running on a treadmill and they increase the incline on the treadmill every 2 or 3 minutes or so until the individual cannot run any longer. So if you can ever find me at like one of my labs that I work at, I could actually put you through one of these tests, but um, since we're doing this all online, we're going to be doing predictive tests. So, this very first, uh, not quite. Well, yeah, we'll go and talk about that. So, this right here, the very first predictive test where you do not exercise. So, non exercise based estimation of maximal oxygen uptake or VO2 max. So, what you'll see here is we have one, two, three, four different equations, and they're actually the first two aren't super busy, but the next two are relatively busy for these things. So I'll talk about these just a little bit. So untrained versus trained, what does that mean? We actually have it defined for you right here. So individual participate in continuous aerobic exercise, 3 or more sessions per week for a minimum of an hour over the last 18 months, and at a good clip, a fairly good intensity. So you're doing this on yourself. So if that's not you, say if you're like someone like myself, where I really only like lift weights and I walk my dogs, I don't really do more intense cardiovascular activities. So I would actually consider myself untrained. So I would put in my height in centimeters, my age in years, and then that would kick it back out for me what's going on there. So hopefully those ones are relatively simple for you to understand. Now, let's look at these a little bit more busy ones. Well, okay. So these untrained ones, here's a particular point to notice. They're predicting absolute VO2 in liters per minute. Now, earlier on, I told you how to that converting this to relative VO2 is going to be pretty imperative because we're going to be comparing these to our fitness standards. So let's just look at that really quick. So here, pretty simple, pretty simple. So if you have liters per minute or the absolute VO2, you multiply it by 1,000, then you divide by the body weight in kilograms. If you have it the other way around, which uh, you really won't need to predict absolute VO2 very much, you would just take the relative VO2, multiply it by body weight in kilograms, then divide it by 1,000. So take note of that. If you're an untrained person and that's what you're doing, you're going to need to figure out your absolute VO2, but then convert it to a relative VO2. Because what we're doing overall, you're going to tell me what your VO2 max is, and that's going to be in the relative VO2 and what fitness category that you're in. So here are our fitness categories. So all of these are relative VO2s. Say if you're a male who's 19 and 38 is your VO2, you're below average. If you're a female who is 56 and your VO2 is 42, then you're, excellent, right? Hopefully that makes sense. If it doesn't, just reach out to me and I will certainly help you out with that. So hopefully that untrained and untrained male and female, those ones make sense. These ones are a little bit more busy, so I'm hoping that if you're doing this on yourself that you're trained. Because, I just hope that everyone trains more than I do. These are actually measuring milliliters of oxygen per minute, not milliliters of oxygen per kilogram of body weight per minute. So what you'll need to do with these is you're going to need to actually, after you figure out this value from these equations, you're going to need to divide it by your body weight in kilograms, and that should kick out the correct number for you. Now, let's just look at a few of these different factors within the equation. So body weight in kilograms, height in centimeters, age in years, duration of training in hours per week. So say if you run an hour 5 days a week, then you would put in the number 5. Now this right here, intensity using the Borg scale. That's why I actually included this before. This is the Borg scale of rate of perceived exertion. So um, if you're working at something that is somewhat of a jog, that would probably be somewhere around 13 or 14. If you're actually like really pushing it, like maybe a 16 or a 17. One good way to kind of assess where you're at is what your average heart rate is during the duration of whatever exercise that you're doing. So this Borg scale, notice curiously it's 6 to 20. So if you just add a 0 to it, it looks a whole lot like heart rate. That we're all around 60 at rest, and we're all around 200 at our max. Now, granted, that's not exactly right, but it'll get you in the ballpark. So if I exercise for an hour a week and my heart rate averages about 130, then I would put in a 13 for that value, right? And then lastly, the natural log of years of training. So with that, you can honestly just Google that, like natural log of 8. Say you've trained for 8 years. You can certainly put that in, um, and it should really answer all of those things for you. Now, with this, I want you to really pick a singular equation for you and show every step of your work. And now I'm going to show you something that I did in Excel. And if you don't want to use Excel for this, you certainly don't have to, but it would maybe help you out just a little bit. So here, let's make this bigger so that everyone can see it. So here, let's say that I'm an aerobically trained male. Right here, um, if you can see right here, you might need to zoom in just a bit, or pause the video or whatever. I put in all of these different parts of the equation, so this 27 and whatever, that's being tied to our kilograms. This one right here, 26 or so, that's being tied to the height in centimeters. Subtraction, 27 or so, that's being tied to age in years, duration of hours trained per week. Where is this? Intensity on the scale, all of those things. Now this natural log, this one right here, training years, natural log, if you want to do it in Excel, how you would do that is just ln, and then you would put all of your parentheses around it, and just, I don't know, really trying to make sure that all of that works out. So let's actually see how this should work in here. So myself, I weigh about, gosh, what am I? About 78 kilograms, 165 centimeters tall. I'm going to lie to you a little bit. Let's say I'm 40. Duration of hours trained per week. Now, this is making things up, so like let's just say I actually train at 5 or so, 5 hours per week. So I go out on an hour jog on Monday through Friday. Intensity, my heart rate's around 130, so there's that. And then training years, let's say I've done this for 4 years, right? So this right here would predict my milliliters of oxygen consumption. And if I wanted to get that into, hopefully this makes sense, into my relative thing, I would be at a 40 or so. 40 because I'm taking that number and dividing it by that. So 40, person who's 40, let's go back and look over here. So I would put in 40 point whatever ml per kg per minute. 40, and let's say I'm 40 years old, which is right in here, 40, I would be above average. Hopefully that makes sense to you. So that's probably the most, I don't know, math heavy part of this. Pretty straightforward, I think. But if you have any issues, please let me know. And those are all the things that you're answering. Really show your work on this. That's really what I want to see. Um, because then I could potentially spot out where maybe you didn't go to, all three decimal places or whatever. All right. So there's one thing. This next one, this test kind of sucks, but I want you to, either video yourself doing it or take a bunch of pictures, pre, during, and post of 1.5 mile run. This, pretty simple. I wrote out all of these procedures. This is all you simply have to do in order to predict your relative VO2 max here. It's 483 divided by time plus 3.5. Now, with this time, the only thing that you really need to know about this is say you finish in 12 minutes and 45 seconds, that is 12.75. So we need this in minutes. And keep in mind that, one whole minute is 60 seconds. So hopefully you're not going to lose points on that. So that, pretty rough test, but warm up beforehand and, just run with your whole heart. This next one, pretty easy test actually. Rockport 1 mile walk. So instead of 1.5 miles, all you have to do is walk 1 mile. Read all of these things. Really, pretty much all you need to do is walk 1 mile, fill in the totality of this equation, and your heart rate immediately upon completion. So that's about it. That's about all you really need to do. You need to, well, also measure the amount of time it took you to walk the 1 mile. So this equation right here, make sure that everything in there is right. This is one of the only places where we have this weight right here, where it's actually in our customary pound system. So don't put in your kilograms there. Don't get lost on that. All right. Um, this last test that I want you to do. So in one of our previous labs, we had you step in up and down on a on a box. And the reason that I wanted it to be about 16.25 was in preparation for this. So, what I want you to do, right, is get on this box, step to the metronome, and then you're going to take your heart rate from 5 seconds to 20 seconds into recovery. So this test lasts for 3 minutes. Where does it say that? Yep, 3 minutes right there. So the metronome will be set at 22 beats per minute for a female and 24 beats per minute for a male. And remember, to get that cadence, you just multiply that number by 4, and that's going to, give us the up, up, down, down, which I believe is, was that 88 and 96? I knew the 96 one. I had to do that 88 one in my head. Sorry, not super good at that. And then here are our equations in order to get our relative VO2 max. You're just going to put in your VO2 max, your fitness category, all of that we were doing before. And then here, the very last thing, we just have a few overall questions for you to answer. I do expect you to write pretty extensively on these. So this lab, it's going to take a fair bit to get through all of these. Again, take at least 24 hours between all of these, ideally 48 or more. This lab, I'm going to try to give you a longer period of time to do it than how I was giving you other labs to do. Maybe like a week and a half rather than 1 week or maybe 2 weeks. We'll just see how the schedule pans out. So hopefully all of that makes sense, and please email me if anything doesn't. So VO2 max, take videos, pictures, all of those things. Prove to me that you're doing these tests, And that is it. All right. Thank you so much.